For basically all of human history, evolution has been this, blind force. It's a story written by sheer chance and unimaginable stretches of time. But that story, it's over. We are standing right now at the dawn of a completely new era, one where humanity is picking up the pen to write its own biological destiny. And let's be really clear about this. This isn't some far-off science fiction. As this quote from our source material points out, the wave is already here. It's not coming, it has broken. The technology is in our labs, it's in our clinics. We don't have the luxury anymore of just debating if this is going to happen. We have to decide what we're going to do now that it's here. And that brings us to this absolutely staggering idea. Our genetic code, the very blueprint of life that for so long we could only read. Well, now it's a document we can edit. We are literally shifting from being the subjects of evolution to its authors. And that is, without a doubt, the most profound change in the 4 billion year history of life on this planet. So how in the world did we get here? Right? How did we make this incredible leap from just understanding our DNA to actually being able to rewrite it? Let's trace that journey for a second. What's really stunning is the sheer speed of all this. It took 50 years to go from finding the shape of DNA to mapping our entire genome, which is incredible. But then in less than a decade, we came up with a tool to edit it. And today, that tool is already in human trials, showing actual promise in curing diseases. The pace, it's just breathtaking. So that brings us to the tools themselves. And we're not just talking about one single breakthrough. We're talking about a convergence of technologies that are basically becoming the scalpels and circuits for engineering a new kind of humanity. Okay, so the first and most famous tool is, of course, CRISPR. At its heart, it's this beautifully simple system that nature actually invented. Bacteria use it to fight off viruses, and we've basically hijacked it to act like a find and replace function for DNA. It can find a very specific genetic sentence, cut it out, and let us paste something new in. The real magic is in its precision. So how does this molecular scalpel actually work? Well, it's really a three-step dance. First, you have this little molecule called a guide RNA. Think of it like a GPS that hones in on the exact spot you want to edit among 3 billion letters of DNA. Then an enzyme, the famous Cas9, comes in and makes a clean cut. And finally, and this is the brilliant part, the cell's own repair kit rushes in to fix the break. That's our window to insert a new corrected piece of code. It's so simple, but it's completely revolutionary.
And this slide just captures the huge dilemma at the core of CRISPR. On one hand, you have this incredible, almost miraculous promise. We could potentially wipe out devastating diseases that have haunted families for generations. But on the other hand, the peril is just as massive. The exact same tool could be used to create so-called designer babies, selecting for traits and making changes that will be passed down forever, with consequences we can't even begin to predict.
Now, the other major tool in this transformation is the brain-computer interface, or BCI. These are devices that build a direct communication bridge between our biological brain and a computer. They essentially listen to the tiny electrical whispers of our neurons and translate them into digital commands, literally merging mind with machine. The potential here is just as mind-blowing as CRISPR. We're talking about restoring movement to people who are paralyzed, or augmenting our own memory and learning. I mean, imagine downloading a new skill instead of spending years learning it. But of course, the risks are equally profound. What happens to your privacy when your thoughts can be read like data? What happens to your sense of self when your mind is directly plugged into AI? And that leads to a really critical, maybe uncomfortable question. What happens when these almost godlike powers aren't available to everybody? We have to seriously consider the very real possibility that these technologies could create brand new and maybe even permanent social divides. This chart here paints a pretty grim picture of a potential future, one split between the enhanced and the naturals. If you have access, you might get preference for the best jobs, cheaper healthcare. You'd have what's being called genomic privilege. If you don't, you risk being priced out, facing higher costs, maybe even becoming a permanent underclass. This isn't just about wealth, it's about a biological caste system. And look, if you think this is all just some distant, abstract theory, look at this number. $2 million. That's the real-world price for one of the very first approved gene therapies for sickle cell anemia. This isn't hypothetical. The economic barrier, the wall between the enhanced and the natural, it's already being built, and it is immense. So these technologies, they don't just challenge our society and our wallets. They go deeper. They challenge our very idea of who we are. They're forcing us to grapple with these enormous philosophical questions about what it even means to be human anymore. For thousands of years, we've thought of the self as, being inside our own heads. But what happens if your memories are stored on a server, or your thought processes get a boost from the cloud? Is you still inside your skull, or has your self become something else, something distributed? Where do you end and the machine begins? Think about it. We value things like resilience or grit because they're earned through struggle. But what if you could just install focus, like a software update for your brain? Does that make the whole idea of character, of authenticity, completely obsolete? Is there any value left in earning it the hard way? Our deepest connections, love, grief, intimacy, they're all built on shared experiences, the good and the bad. The pain is part of what makes the joy meaningful. So what happens to those bonds when we can just delete a painful memory or dial down our grief? What happens to the very fabric of our relationships? And then there's the twist. We've been talking about all the dangers of enhancement, but what if the bigger danger is not enhancing? To survive what's coming, climate change, future pandemics, maybe even leaving Earth, do we actually have a moral duty to upgrade ourselves? Could saying no to evolution actually be the bigger ethical failure? All of this brings us to the final, stark choice that's right in front of us. Are we going to be responsible stewards of these incredible new powers? Or are we going to let them tear our species in two? Now, the good news is people are thinking about this. The source material talks about a framework, a kind of human specification accord. This would involve things like an international agency to monitor gene editing, a bill of neural rights to protect our own minds, and critically, a way to fund access for everyone and to protect the right to stay natural.
Because the two paths forward could not be more different. One is a future of stewardship, where we act as careful custodians of our own biology, sharing the benefits. The other path is speciation, a future driven by unregulated markets and a new kind of arms race, leading to a permanent split in the human species.
As the source puts it so powerfully, the pen that's writing the next chapter of humanity, it's already moving. We can't stop it. Our only choice now is whether we guide that stroke with wisdom and with our eyes wide open. And so we'll leave you with that final thought. For the very first time, our evolution is in our hands. The question is no longer what can we do, but what should we do? Will we be equal to this incredible, terrifying power that we now hold over the blueprint of life itself?